Okay, this is going to be your first video. Hopefully we have others, but we're at least going to try this for today. This is the rest of solving systems with elimination. If you'll remember today, the goal was to get rid of a variable by canceling out variables that had opposite coefficients. If you'll look at our first example here, I have 3x and 5x, and then I have negative 2y and 4y. I don't have opposite coefficients. I do have opposites though. I have a negative and a positive here, so I could cancel these if they had the same number. So what I'm going to do is take this top equation and multiply it times 2. That way when I do this, I'll have a negative 4y here and they'll cancel. So this becomes 6x minus 4y equals 38. And to that I'm going to add the bottom equation. So my y's cancel, so I end up with 11x equals 55. Solve that. And you should get, by dividing by 11, that x equals 5. Now that I know x, I can find y, and I can plug it into any of these equations I have. It doesn't matter which one. I'm just going to go with the top one. So I have 3 times 5 minus 2y equals 19. Go ahead and multiply. So I end up with this. Negative 2y equals 4 because I'm going to subtract my 15. So y is going to be negative 2. So my solution to this system is 5, negative 2. So the new part of this from what we did in class today is that you're not going to have coefficients that automatically eliminate, and you may not even have same coefficients, so you're going to have to multiply by something to get them there. So let's try another example. So this one, it's a lot like the second one. I do have opposites. I have a negative and a positive on the x, and I also have a negative and a positive on the y. I happen to know that I can multiply 5 times something and make it equal 15 a lot easier than I can multiply 9 times something and make it equal 12. So I'm going to take this top equation and I'm going to multiply it times 3. So I end up with negative 36x plus 15y equals negative 15. And then the bottom equation stays the same. And so I can add them up. These cancel. So I have negative 27x equals negative 9. Well, when I divide this time, I'm not going to get a pretty whole number. The two negatives cancel and make a positive, but 9 over 27 just reduces to 1/3. So I have a fraction. It's okay to have a fraction. It's not the end of the world. I'm going to plug this in. Both of these equations, my x's, are multiples of 3. 12 is a multiple of 3, and so is 9. So 1/3 is going to be really easy to deal with. I'm going to do the bottom one because my x is positive. So I have 9 times 1/3 minus 15y equals 6. Well, 1/3 of 9 is 3. So to finish solving this, I'm going to get another fraction when I divide. But this time, this one's going to be negative because 3 is positive, but 15 is negative, and so I'm going to end up with a negative 1/5. And so my answer to this looks like this. So I have two fractions. Everything's all good with that. Fractions are numbers too. Okay, let's try another one. Now, if you look at this one, I don't have any opposites. I have 2 positive x's and I have 2 positive y's. I don't even have anything that I can easily see turns into something, okay? I can't do 4 times something and get 6, and I can't do 7 times something and get 5, or the other way around. I'm going to have to multiply both of these equations by something. The least common multiple I can think of between 4 and 6 is going to be 12. 4 times 3 is 12, 6 times 2 is 12. So I'm going to turn these both into a 12, but I need one to be positive and one to be negative. So let's make the top one positive. So to make the 4 be a 12, I'm going to have to multiply by 3. And in order to make the 6 be a 12 but also eliminate, I'm going to have to multiply by negative 2 so that I get a negative 12. So the top equation becomes 12x plus 21y equals 18. And the bottom equation is negative 12x minus 10y equals negative 40. But now my x's eliminate. And so I can go ahead and just add up. So 21 minus 10y is going to be 11y. And then 18 minus 40 is negative 22. So y is going to be negative 2. Now to find x, I just could continue what I've been doing all along, and I'm going to plug it back in. So I have 4 times x equals, plus 7 times negative 2 equals 6. So this becomes 4x minus 14 equals 6. So I have 4x equals 20. So x is 5. So you write your ordered pair. We're good to go. We have another one. I don't have opposites. 2 positive x's and 2 negative y's. So I'm going to have to multiply both of them by something. I also don't have nice pretty numbers, okay? I got 3 and 4 and then 8 and 5. I know that 3 times 4 gives me 12. The lowest common multiple here is going to be 12. So I'm going to do the same thing I did on the last one. I'm going to multiply the top one by 4 so that I can get a 12x. And then I'm going to multiply the bottom one by negative 3 so that I can get a negative 12x. This way I have same coefficients, opposite signs. So I have 12x minus 32y equals 52. Then I have negative 12x plus 15y equals negative 18. Add these together. Your x's cancel. Negative 32 plus 15. So I have negative 17y equals 34. So when I divide, y is going to equal negative 2 again. Plug it back in so you can find an answer. I'll use the second one this time. So we have 4x minus 5 times negative 2 equals 6. Well, this negative and this negative are going to make a plus, and then 5 times 2 is 10. So I have 4x equals negative 4, because when I subtract 10, that's what happens, and then I get x equals negative 1. So there is my point of intersection. Okay, one more question. This time we have a word problem. So the Lees spent $31 on movie tickets for 2 adults and 3 children. The Macias spent $49 on movie tickets for 3 adults and 5 children. What are the prices for adult and child movie tickets? So our variables, we have A for adults, and we have C for children. And so we're going to have to write 2 equations. The Lees had 2 adults and 3 kids. It's $31. And then the other family had 3 adults and 5 children for $49. Again, this is another one of those where I don't have opposites and I don't have coefficients that match. So I'm going to have to multiply both things by something so I can get opposites and matching coefficients. 2 times 3 is 6 and 3 times 2 is 6, so my least common multiple here is 6. It's smaller than my least common multiple here, which is 15, so that's what I'm going to do. I'm going to turn this into a 6 by multiplying by 3. Then I'm going to make this one a negative 6, so they'll cancel by multiplying by negative 2. So I get 6a plus 9c equals 93. Then I have negative 6a minus 10c equals negative 98. I'm going to add them up so I can get stuff together. My a's will cancel, leaving me with negative c equals negative 5. Well, this doesn't even make sense because I can't have negative 5 tickets, but that's because my c is negative, so change both signs. So c is 5. So there were 5 children's tickets. So now I got to figure out how many adult tickets there were, so I'll go plug it in. 2a plus 3 times 5 equals 31. 2a plus 15 is 31. So 2a is 16. So A is 8. So there were 8 adult tickets and 5 children's tickets. Well, that's it. Okay, that's all there is to this, the rest of this day. It's just adding a couple of steps to what we did today. I hope you enjoyed the first video. I will see you guys tomorrow, and hopefully we can get our homework done.